Good morning, girls and boys. We're back in the 737-800NG simulator cockpit here, and today I'm going to show you all the panels that are in this aircraft and show you what they do, or basically what they do. And then we'll go through a flight from Brisbane to Perth. In this part of the video we'll go through to cruising height, which will be probably 39,000 feet, flight level 390. First of all, disclaimer, none of what you see in this video should be used in real flight or flight training. I'm not a flight trainer, so all the information that is given here is gleaned from the internet and various publications. So it's my slant on things. The cockpit itself is not identical to a 737-800. It's pretty close. All the instrumentation is pretty close. It's only the aesthetics that are possibly not quite right. So let's go through these panels. You've got the overhead, the mode control panel, which is the MCP, the MIP, which is the main instrument panel, the TQ, which is throttle quadrant, and the radio panel, and then the controls. So we'll go through that and show you what's what with that. Starting from the top of the panel, we have our alternate flaps and flight controls, etc. Spoilers, which can be used in the case where the main hydraulics go down. We have our yaw damper switch, which is the yaw damper stops the nose of the aircraft wandering from side to side. Our navigation displays, we can set them either on both on one, both on two, or what is called normal, which automatically does it. That's the VHF nav, which is very high frequency navigation. The IRS, which is inertial reference system. The FMC, which is the flight management computer, and that's how we set that, whether they're on the captain's or the first officer's side. The same with the displays, we can set that in the same manner. And then we have the fuel temperature gauge, the fuel panel itself, which has the cross-feed switch, which is for feeding fuel from one tank to another. The two forward tanks, which is the central tanks in the fuselage, and two tanks in each engine, the switches for them. Coming up to the top of the next section, we have our electrical panel, which shows our amps and volts, etc. The switches for switching from battery power, auxiliary power, and on the right we have ground power, generator 1, generator 2, and APU. Now the APU is the auxiliary power unit, which is a turbine engine, small one, in the tail cone of the plane, and that supplies pneumatic power and generators. It has a small generator in that which supplies power to the aircraft before it's on either ground power or its own generators from the two engines. Our standby power, which comes from the batteries, etc., that's the standby switches. Ground power switch, which is self-explanatory. Then we have our main power switches from the APU, the auxiliary power unit, and the main generators, one on each engine. We have our APU exhaust gas temperature, EGT, temperature gauge, and the switch down the bottom there, which is the APU switch, auxiliary power unit switch. Coming up to the top, we have our brightness controls for the panels, our equipment cooling, our emergency lights, which run down the either side of the aisle in the aircraft. No smoking and seat belts, of course. The attendant call, which we can press, and that calls our hostie for a cup of coffee. And our ground call next to it, our windscreen wipers, which we haven't got any on this one, of course. Coming up to the next panel, we have on the next panel over there, we have the window heat. The windows have to be heated because at the very low temperatures at altitude, which is usually around about 52 degrees, minus 52 degrees Celsius, the windows can crack. So that's the window heat goes on pretty much as soon as we fire up. And the pitot heat. Now the pitos are the tubes that poke out the front of the aircraft to sample the air in still air for the differential pressures within and without the aircraft. Anti-ice, which is self-explanatory, on the wings and the engine. Puts bleed air, hot air into those areas. Our main hydraulic switches, which is electrical and engine hydraulics. Our door indications, whether they're open or closed. Our cabin altitude pressure, you might say, gauges, and its associated associated knobs over here to set. That's the altitude, the flight altitude or the landing altitude, so that the cabin pressure is kept at constant at around about 8,000 feet, I believe, so that we don't suffer from hypoxia, which is lack of oxygen. Rate of climb and descent. Then we come up to the top of the next panel. Most of that is to do with air conditioning and setting the temperatures in the cabin and the cockpit, forward cabin, aft cabin, etc. Then we have our duct pressures, recirculatory fans in the cockpit, our left and right packs, which are the air conditioners, the isolation valve which gives bleed air from the APU. We have the APU bleed switch and the wing anti-ice switches. I've just explained that one. Then coming down we have our what do we have here? We have our lighting, which is the wheel well light, a wing light, anti-collision position and strobe logo lights. We have our two main switches for the starting of the engines. The APU switch I've mentioned, taxi light switch, runway turn-off lights, landing lights, fixed and retractable. Coming down through to the main instrument panel across here, we have a clock, of course. We have the PFD, which is the primary flight display on the left, the ND, which is the navigation display on the right. They are controlled by a switch above it, which can swap to various configurations of those NDs or those displays. We can do the same for the lower ones, and we can swap until we're fired up. That won't happen. In the centre we have our upper engine parameters, or upper display of those, and then when it's fired up we have our lower one, which has the secondary displays in it. Either side of that we have our flight management computers, our FMCs, one either side. They will be fired up with the once we fire up the engines. Then we have the landing lever there, landing gear lever, and across the top here we have our FMC, which is flight mode control panel, our FS, EFIS, which is the electronic flight instrument system, what we call our 6-pack, because it has 6 warnings on it for various things. The main panel across the centre, which has our course, our indicated airspeed, our IAS or Mach, our heading, our altitude, and the same pretty much on the first officer's side. We have our switches for our autopilot and various other switches to do with autopilot here. our VNav, LNav, which is vertical and lateral navigation, VNav, LNav. We have the same FS on the first officer side. Coming down through to the centre, we have our TQ, our throttle quadrant, which has the speed brake on one side, flaps lever on the other side. The flaps go from 0 degrees through 1, 2, 5, 10, 15, 30 and 40 degrees. Coming up to the top, we have our throttles with our disengagement for auto throttle on the end of the handles, and our togo buttons, take off and go around thrust. Ahead of that we have our reverse levers, which reverse the thrust on the engines. Some cones come out and the thrust is actually directed to the rear. That happens on landing. The speed brake is used in flight to the flight detent mark, so that it can slow you down in flight if you're running a little bit quick, and then to the full up it does that automatically, so long as it's set prior to landing, and that pops up the flaps on the top of the wings to kill the lift when you land. The trim wheels on either side, they provide trim to the rear stabiliser. The whole stabiliser moves to trim the aircraft in the pitch motion. Then we have the two engine fuel inputs, left and right, or first 1 and 2. I'll explain those when the engine's being started, and the park brake. Then we come through to our radio panel. On the radio panel we have VHF, which is very high frequency. That's used for air traffic control, etc. We have our nav radio, navigation radio. That's set for homing in on the various beacons or various systems that are used for bringing the aircraft into the correct parameters and so on for landing in the instrument landing system. Our distribution panel for our audio, and then we have the ADF, which is automatic direction finding. That's set also for radio beacons, so that the aircraft can home in on the various beacons. We have the trim for nose and ailerons here, cockpit door open and shut, whatever. Another panel which I've introduced, which has a printer, and it's actually got 4 buttons here for firing up the 4 computers that run the system. Then we have transponder, which is used by ATC to track aircraft. We set that to a certain value here, and that's used by ATC to track us on radar. Then we have the weather radar, and that'll be tested later on. I'll show you that. Weather radar panel. We have our cargo hold panel, fire panel, and that has its test panels as well. Then we have the fire panel, which has extinguishers for engine 1, 2 and the APU. That has its tests as well. So that's the radio panel. Coming to the controls, flight controls, our yoke, which goes to the right aileron, to the left aileron, and we go up or down, whichever. So that happens the same on the first officer side, right, left, up or down. Then we have down in the base here, we have our, you can see that, we have our pedals either side of the central pedestal there. We just see them at that point, and that is the pedal on each side. That happens on the first officer's side as well. They're used for the rudder and also for the tow brakes, so that's to bring the aircraft to a halt. Other than that, we have our tiller, which operates the front wheel steering on the ground, because the rudder has no authority until it reaches about 45 knots and has air across the surface. So it's steered by the tiller until the rudder has authority. We have our what we call our whiskey compass, which is the standby compass, which basically is the same as any other compass that you have. It's not actually attached to anything. It's purely an alcohol-filled compass, which gives us our heading. Up the top of here, which I didn't mention, we have our auto brakes, auto skid, our speed references for takeoff and landing, and setting our N1. Now N1 is, I don't know what N stands for, but that's the low speed fan at the front of the engine. N2 is the higher speed compressor further into the engine. That just about sums it up. The rear panel in this case, the rear overhead panel, is a dummy in this case because I haven't actually worked on that one, so there you go. And then on the side panel here we have our navigation displays and our instructor station. We have our navigation information. At the moment we are here at gate 15 at Perth Airport, which shows all the taxiways, etc. We can change that to any airport anywhere in the world. I think I've got 24,863 airports into there, and that's true. I'm not making that one up. And we can also have our instructor station here, which also shows information. In this case, what I've got sitting there is ready for putting a route into the FMC, the flight management computer, and we can introduce a flight plan. So we'll do that shortly. That's it. Okay, now that we've done that, let's show you the setup of the cockpit. Now at the moment we're at Brisbane International Airport, gate 22. Normally when we're coming into the cockpit, it would be what they call cold and dark. At the moment I've got the ground power switched on, which has lit up all our panels and given us power for the various systems to start. We've got our fuel pump on our central tank, one of the fuel pumps on, so that we can start the APU, which is the auxiliary power unit in the tail cone of the plane. It's a small turbine engine which provides us with bleed air, pneumatics, and generates the current for all the startup systems and so on before these main generators come online. So at the moment we are not quite cold and dark. Also I have loaded the FMC, the flight management computer. I've loaded that up with our route and our flight plan to Perth. That's normally done the first thing you do when you come into the flight deck while the passengers are coming on board. So what we'll do also at this point is bring the catering on board. So to do that we need to open some doors and make sure that everything is open. So by opening the forward, left and right, we have the passengers coming in on the left hand side here, and the catering comes in on the right hand side, entry door or access door, and then the forward cargo and aft cargo doors will be opened. When I start boarding the passengers, also the luggage and cargo will be boarded on the right hand side of the aircraft. So we've got the door open. Let's call for the jetway. Request jetway. Okay, so the jetway will be coming in and attaching to the left hand side forward entry here for the passengers. The catering should arrive fairly shortly into that area, and then we'll start boarding the passengers. Okay, our jetway is coming in now, and we shall call for the passengers to board. I think our jetway's come in. It's hard to tell. Okay, our cabin crew are on board, so cabin crew, start passenger boarding. Okay, so the passengers all come on board. So while that's happening, we would normally enter all the details into our flight management computer. We've done that, so we're basically ready. And now the next thing we can do is to start our APU. That takes a little time to wind up and get moving. At this stage we can switch on our no smoking and passenger seatbelt signs. The no smoking sign is normally on auto in the aircraft these days because no smoking is the norm, so the signs are on permanently. But the no smoking sign on particularly on these aircraft are used by the flight crew to give the warning to the cabin crew that they need something or they want to speak to them. So that's usually switched to the on and then the off to the on and then back to the auto position. The flight crew then know to get onto the intercom and interphone and speak to the captain or the first officer. Seatbelt signs, as I said, is completely on. We can call the cabin crew for our coffee with the ding dong, and hopefully we get a cup of coffee. Our APU has now come online, so we switch the bus on and we're now on APU power, so we can disconnect from the ground power and disconnect ground power. Fine, and our passengers should be boarding soon. Hopefully that won't take too long. Other than that, we now can set our parameters on, here come the passengers, our parameters on the mode control panel, which I've explained before how this operates. And we need to set up our weight and balance. I know from previous experience we're going to have 74.5 tonne on board. Our reserve fuel will be 1.4 tonne, and our cost index is 15. Now the cost index can range from anything from 5 to 100. It's just a figure that the company's put on the aircraft, which goes into the FMC to set whether you fly fast and inefficiently, so to speak, or use more fuel, or slightly slower, less fuel. So it's a balance between making sure that the company makes some money. And we're flying at 39,000 feet today, which is flight level 390. That goes in. Now once we've done that, we go to our takeoff page, and flaps 5 today for takeoff, and that gives us our takeoff speeds, our V1, VR and V2. V1 is the decision speed before or at the point where we can stop the aircraft before the end of the runway if anything happens. V2 is the decision speed to continue, and VR is the rotate speed when you bring it off the ground. So V2 is set in the IAS, indicated airspeed dial here, of 155 in this case. Our runway heading is 016, even though it's designated as 001. It is actually, the actual heading is 016. I normally set the course on that as well. Then everything's set. Okay, our first transition is 10,000 feet. We set our flight altitude at 39,000 feet, and our landing altitude, Perth Airport, we'll look that up in a moment. I'm not sure, I think it's 400 and something feet. Not sure. Let's have a look at Perth Airport. We have on the side panel here our pad, which has all this information in it, the flight plan and the various navigation charts and so on. So we can bring up the airport chart for Yankee Papa Hotel. Right, open the charts for Perth Airport, and we will find, under the taxi charts, we can find our airport information, and there we go. And right, our elevation for Perth Airport, I was totally wrong. I was thinking of Kalgoorlie. Totally wrong. Our airport elevation is 67 feet, so we'll set it at 50. Right, and at the same time we're going to go back into here and bring up our charts for Brisbane, and we can have a look at Brisbane Airport. Since it has changed, it has now got parallel runways, and in our case we're going off on 01 right, and there is 01 left, and the reciprocals as well. That's come into force this year. Now, I have actually flown this in real time, really air time, with Qantas, and I don't mean I've flown it. I've been a passenger about 14 times, so I fairly well know the routine with coming out of Brisbane and back into Perth, so that won't be any problem. So let's have a look at our information for Brisbane, and we are at gate 22, and we will be taxiing via a link which gives us C3 to taxiway B5 and then to taxiway A Alpha. So Charlie 3 to Bravo 5 and then Alpha to runway 01 right. Now our passengers have boarded. It sounds like all our luggage is on board. We can now go through and shut the doors, and at the same time as the door is shutting we will undock our jetway. Okay, there goes our jetway. We'll just check and make sure. Yep, all our boarding is complete. So, okay, so we can close off the front right and the forward and aft cargo doors. They can all be closed off. That's fine. And now that we're all complete in here, we'll flick this light off and get ourselves underway. Okay, so the first thing we call for, ready for departure, right? So we're calling for the tug to come in and push us back so that we can taxi. And here comes our tug. So,
hello Captain, we are ready for pushback.
Ready for pushback, and the parking brake is set. Now that we can put our bleed air on from the APU so that we can spool up our turbines, our main engines, and our isolation valve.
Locking gear.
Okay.
Departure check completed. Bypass pin inserted. Release parking brakes. Commencing push.
Parking brakes are
All engines
released.
Clear.
Okay.
Start at will.
We are ready for a start. We're now being pushed back from the terminal. Our number 2 engine goes to ground to start, and we're looking for 25% of the N1, which is the front fan, the low pressure fan at the front of the engine. We look for 25%. There it goes. Introduce fuel. Engines are spooling up.
Good afternoon, ladies and gentlemen. Captain and the entire crew would like to welcome you aboard. May I kindly ask you to fasten your seatbelts now, making sure they are pulled tight. And for your own safety, we recommend that you keep your seatbelts fastened during the entire flight. My name is Karen Sharp. I'm the purser on your flight today and do wish you a pleasant stay on board. You are welcome to use your own electronic equipment after takeoff when the fasten seatbelt signs above the cabin station.
Right, it's reached 56% and flipped off. We start engine 1. Engine 1,
All mobile phones should be switched off
fuel
completely
1.
at this time. Further details are available in your in-flight magazine, which you may find in the seat pocket in front of you. May we please remind
20%.
you once more that you store heavy baggage under your front seats and not in the overhead
25%.
as they may shift during flight. Thank you.
And normally we'd
Ladies and
keep our
gentlemen,
hand on that.
we will acquaint you now with the safety features of this aircraft. Please pay attention to the flight attendants. First of all, we demonstrate how to fasten and unfasten your seatbelt. If there is a loss of cabin pressure, oxygen masks will automatically drop from the cabin ceiling. If that happens, pull one of the masks towards you and press the opening firmly over your nose and mouth. Then assist any children travelling with you.
Right, our engines have started. We turn those to continuous. Put all the fuel pumps on. We should have switched our galley on earlier. We now switch to our generators, our engine generators. Our hydraulic switches come on, both electrical and engine. Our wing anti-ice and our probe heat ice. Our air conditioning packs can come on and our bleed air can come off. We have set this panel. Our anti-collision lights come on and strobe light comes on. Right.
Pocket in front of you. Please take particular note of the location of the 8 emergency exits, which are all identified by the word exit. Illuminated escape path markings will guide you to these exits, and please keep in mind that the next available exit might be behind you. If you have any further questions, please do not hesitate to ask one of your flight attendants. Ladies and gentlemen, we are now ready for takeoff.
Okay, now I should have mentioned earlier that we do go through a complete checklist to check all the switches and annunciators, etc., before we would have done anything else. So I normally would have gone through that checklist. Now the other thing that I didn't do earlier was go through the actual checks for the fire panels and so on. So I shall do that now, since the cabin is ready. And good engine start.
Set parking brakes. Waiting your confirmation for good engine start.
Good engine start. Okay, now we've done that. Okay, we can do our checks. The first thing we should have checked was that all the annunciators right through were lighting up, and they do, so that's fine. Back to normal there. We have also checks on these on both sides. The first officer would do his as well. Then we come through to
Unlocking gear.
checking the panels. We have our fire panel here. We check that. That works fine, and both those work okay. We have our cargo hold fire panel, so we can test that as well, and then we arm those two extinguishers. Coming through to the weather radar, we can check the weather radar,
Monitor radar display.
and that shows up on the
Disconnected. Bypass pin removed.
main
Go
panel.
around. Wind shear ahead.
We can check our TCAS, which is the traffic avoidance and collision system.
TCAS test passed.
So they will pass. Then the ground proximity warning system.
Light slow. Left is clear. Right is
Hold
clear.
up. Wind shear. Wind shear. Wind shear. Terrain. Terrain. Pull up. Obstacle.
So they
Obstacle.
would have been
Pull up.
checked earlier, but I've just done it now to show you
Sink rate.
how it's done.
Pull up. Terrain. Plus 100. Minimum. 50. 40. 30. 20. 10. Wind shear. Wind shear. Wind shear. Too low. Terrain. Caution. Terrain. Caution. Terrain. 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 Pull up. Caution. Obstacle. Caution. Obstacle. 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 Pull up.
Okay, that's a very long one. I've got to shorten that one. At this point, we should have, as soon as the engine's fired up, we go onto our engine generators. We can now switch off the APU. It's not required. We're on the internal power, and okay, we are ready to taxi. We have our clearance, and we now put the taxi light on. Everything else is fine. We give the ding for the girls up the back, and they've already indicated the cabin is secure. Release the parking brakes. We taxi via C3 here. The graphics will be a little bit jittery and juddery because it's being very well overloaded with everything that I've got on this system, and without spending $1 million on graphics, we have to put up with that. Okay, we are on taxiway Bravo, and we will go via the Bravo 5 link to the left here. Bravo 5.